So, example number 2. Let's read. Compute the axial stress at the cable used to keep the bar stable while supporting the weight at the end beam. The cable diameter is 24 millimeters. Assume pulley is frictionless. So in this type of problem, what we're going to do is we're going to proceed with the statics principle, or the statics of rigid bodies. So what are we going to do? First is we're going to draw the free body diagram of this whole figure, eliminating the support reactions. So how are we supposed to do that? So let's go back to statics. I know you have learned so many things about your statics. So first is, let us draw the figure again. Okay, let me repeat. Let's draw the figure. Wait, it's always eliminating. Let's draw the figure. So this is the beam or the bar, and then the bar is supported by a tension cable. So nganong tension din na siya? Because as you observe, the way it is being supporting to the whole system here, it serves as a suspension, no? So suspension siya in such a way nga gi-connect ang cable padung sa pulley padung diha. So that's the concept of cables. So for cables, always remember that the force would be pointing away from the system. So I'll call this as tension T. And also another, by the way, this is 50 degrees. And then you have also another tension here. We call it the same tension. Ngano di ay? Because of the concept sa pulley. It says here that the pulley is frictionless. So when frictionless pulley is being applied, if this is T1 and this is T2 in this case, since frictionless man, then somehow T1 is just equal to T2. Therefore, I can just denote T1 and T2 be equal to T. Right? So that's how we proceed with the tension. So let us continue. Since we have this tension cable already, let us also do not forget nga naatay 75 newtons. 75, what's happening? 75 kilonewton load, and it is directing downward because of the nature of the load. So it serves as mo'y iyahang nature sa pagbutang nato diha sa load. So mura siyang naka-pull diri padung ubos tungod sa iyahang weight. The weight is always directing downward. So mo na yang concept. So you have 75 kilonewtons. So also in this portion, you have to place reactions. So I'll place reactions. I'll call it as R vertical. So nara ninyo kung upward ba or downward. And then I also have R horizontal. But actually, we're not looking for the amount of these values. Ang problem ningon siya nga, we're going to find the stress sa cable. So unsa man day atong buhaton? We are going to solve for the values of that tension T, or the value rather. So unsa na to siya pag-solve? Since this T here is inclined at a certain angle 50, So what we're going to do is get the components. So let's get the components. You have the component here. This is t cosine of 50, and you have t sine of 50. No? So nanakay t sine 50 and t cosine 50. Then what's next? Since we don't need these values, somehow diha tamag do the summation of moment at r here. Diha tamag moment, meaning to say ma-cancel out na siya from the equation. So summation of moment r equal to 0. So clockwise positive, counterclockwise negative. So proceed. Solve na to ang r, or I mean ang t. So you have the t sine of 50. It rotates. Ang motion niya counterclockwise, so it's negative. And then you have this one. Wala siya ilapot because it was just only passed through this portion. So wala na siya lapot from the equation. So t sine 50 times the value, no? Kana siya 2 meters. And then you have here rotation padung dire. So asa siya mo rotate? Clockwise, and that's positive. So 75 times pila man na siya? 75 times 6. Sige ni siya sibog 75 times 6 equal to 0. So para ma-solve na nato ang t, and that is equal to 75 times 6 over 2 sine of 50. This is our axial force. So let's solve for that force. 75 times 6 over 2 and sine 50. So you have 293.717. And the value here is in kilonewtons. This is our axial force sa ato ang cable. So with that, we can now proceed in solving for the stress, since we're tasked to solve for axial stress sa cable. And then ningon sad siya nga ang diameter sa atong cable is 24. So solve na to. The stress is equal to P over A. Our P here is equal to the T, which is 293.717. Our area, what is the area? Our area here is, ano man ang atong area? Ang area nato kay diameter man, so it's a circle, pi d squared over 4. So you have pi, the d is 24 square over 4. So the area is, let's solve. It's pi times 24 square over 4. So it's 452.38 mm square. So that is our area. Since naman the area, we can now solve for the stress. The stress is 293.717 over 452.389. So ang answer ani kay 717 divided by 452.389. You have 0.649, and that is kilonewtons per square mm. Or we can rewrite that as into newtons, 0.649, then you multiply that with 1000 para mahimo siyang newtons per square mm. So giunsa man na siya pag 1000. Remember that in 1 kilonewton there are 1000 newtons. So the value here, it's going to be, the stress is 649.258, and that's newton per square mm. So what is newton per square mm? So newton per square mm, that's kuan. Let's go back to Pascal. What is Pascal? Pascal is equal to Newton per square meter. And converting this m square into mm, we will have 1 over m square. Conversion niya is 1 m square, or 1m rather, is equal to 1000 mm. Yeah, since naka-square man ni siya, then we also have to square this one. So distribute and distribute. So we have 1 over m square is just equal to 1 over 1000 square mm square. So they're just the same. So therefore this is just 1 over 1 million square mm. So this is our conversion. You have Pascal is equal to Newton over 1000 ka square mm. I mean 1 million ka square mm. So it's going to be multiplied there. So 1 million ka Pascal di is equal to n over mm square. So what is 1000 Pascal? I mean 1 million Pascal. So we can rewrite 1 million and Pascal. And that's equal to Newton over mm square. Or di, that's equal to 1 MPa, and that's Newton over square mm. So to finalize our answer, our stress di is equal to 649.5 no 258. Instead of using this, we can now use this one, 1 megapascal. This is our final answer.